Today's problem is minimum steps to have sum, difficulty medium. Given an array, find the minimum number of operations required to make the sum of its elements less than or equal to half of the original sum. In one operation, you may replace any element with half of its value with floating point precision. Okay. Let's look at the constraints and then the examples. So the size of the array will be between 1 and 10 to the 5th, 100,000 inclusive. The elements in the array will be between 0 and 10,000 inclusive. Expected complexity n plus k log n. Okay, what is k? I'm going to have to look at that. Auxiliary space, O of n. Yeah, we're going to use a priority queue. Okay, heap. Greedy. Yes. Okay, yeah, all those made sense. I'm not totally sure what k is there. I guess it would have to be the number of operations, the number of operations, the number of times that we have something. Okay, so let's look at what we can do here. Well, actually, let's look at the examples. First array, 8, 6, 2. So we need to know what the initial sum is. 8 plus 6, 14 plus 2, 16. So we need to get that down to 8 or less, right? Well, it makes sense if we want to do that as quickly as possible, that at each step we will have the largest number in the array. So first time through, we'll have the 8. That is going to leave us with 4, 6, and 2. The next time through, we would have the 6. Leaves us with 4, 3, and 2. Now at this point, we can have any of those. They're having the 2, which I don't think is the way it's going to work, but that does get it down to 8. Look at the second one here. This brings the floating point into play. So we have 9, 1, and 2. 9, 10, so that's 12. We need to get it down to 6 or less. So what we can do is cut the 9 in half. That'll give us 4.5, which is 4, 5, 6, 7.5, still too big. So we have, again, the largest number, 4.5, goes down to 2.25, and now we have 5.25, and that is less than or equal to 6. So okay, maybe we can walk through an example here with number 1. All right, so first thing we want is a priority queue, a max heap. We want these in descending order because we want it to be easy to get to the largest number. And in a max heap, the largest number is on top of the heap. So default for a priority queue is ascending order for ints or doubles in this case. And we want descending order. So we use this collections dot reverse order as the input to the priority queue. Double case sum 0. Let's do this. Let me get a pen. If I move this over here. All right, the sum. Now we're going to loop through every element in the array. We're going to add, get off of there. We're going to add each number to the sum, and we're going to put each number in the heap. All right, so we already know that by the time we finish this loop, sum is going to equal 16. Okay. The heap is going to be in descending order. So 8, 6, 2. What is half? That's our target. We need to get to half of the sum. So sum divided by 2 in this case. And I'm not writing these as floating points, but in practice they would be. So what we need to get down to here is 16 divided by 2, which is 8. Count is 0, while sum is greater than half, which it is. Take the element from the top of the heap, which is 8. Okay. Divide it by 2, which is 4. Subtract it from sum. Okay. And add it to the heap. Now, we already pulled this number right here. It's gone. So when we add 4 to the heap, it's actually going to go here. Yeah, I'm still going to run out of room there, right? Okay, and then count. Increment count. So count is now 1. Still in the while loop. Is sum greater than half? 12, 8. Yes. Top. Pull the number from the top. It is going to be 6. Let's take it off there. Half top is 6 divided by 2, which is 3. Subtract 3 from the sum. We've got 9. And add half top to the heap. Well, okay. Yeah, we can squeeze it in there. 4, 3, 2. That's our heap now. And increment count again. So that's 2. All right, is sum greater than half? 9 greater than 8? Yes. Pull the heap. The element at the top of the heap is 4. Let's remove it. Half top is 4 divided by 2, so that is 2. And then subtract half top from sum. It's 7. 7. Add half top to the heap. Well, okay, that's easy. We can just put it here. And increment count. 3. Is sum greater than half? 7 greater than 8? No. So we're done. And we return the count. The count is 3. And actually, let me move this over. But that is the number that we're looking for. So over here, output 3. Okay. Pretty simple example, but I think this is really on the low end of medium, like the really low end of medium, because you look at this and the instructions say add up all the elements in the array. That is your sum, and at each step you can cut one of those numbers in half, and you want to minimize the number of operations that it takes to have the sum. So obviously you want to cut the biggest number in half. Easiest way to do that is create a max heap. I mean, well, especially since they've included in the topic tags down here, yeah, use a heap. Use a greedy approach, meaning cut the biggest number in half. And that's it. Now, I'm going to try and compile and run this. I've had a lot of trouble with this site today as far as trying to submit things, and they just don't run. Okay, so that's fine. Here, let's try this. Oh, it did run. Okay, good. All right, so that's it. I mean, granted, it was kind of easy, but I encourage you to still like the video and subscribe to the channel, and we'll see you next time.